the most lucid image of Proxima b has been released by the James Webb Space Telescope. Only 25 light-years from Earth, the celestial body Proxima b has enthralled astronomers all over the world with its fascinating features. It invites us to investigate its mysterious realm as one of the nearest exoplanets ever found. Despite being close by, Proxima b is a different world from our own, providing an intriguing look into the universe's diversity. Discover the mysteries of Proxima b, a planet that defies expectations and challenges our knowledge of habitability and extraterrestrial life. Come along on an incredible trip with us. Proxima b has remarkable size, with a mass about 30% more than Earth. This planet's comparatively short year, just 112 Earth days, surprises us nevertheless. Its orbit around the star that controls its existence, Proxima Centauri, is the secret to its brevity. Less than 5% of the distance between Earth and the Sun is covered by Proxima b's orbit, which is limited to 7.3 million kilometers from its star. You would think that because Proxima b is so close to its star it would be a fireball, but you would be wrong. Compared to our Sun, the tiny red dwarf star Proxima Centauri emits a lot less energy. Imagine looking up at Proxima Centauri from the surface of Proxima b. 3 times the size of our Sun, the star would look as a dull red orb. Interestingly, Proxima b might be located in its star's habitable zone, which could lead to the formation of liquid water. However, we must face the unpleasant fact that Proxima b is far from a perfect second Earth before we can imagine an interplanetary journey to this alluring place. Tidal locking, a phenomena that is probably occurring on Proxima b, is the dark side of the planet, which means that one side of the planet is always facing its star, while the other side is stuck in a state of everlasting darkness. Any possible life forms would find the environment unfriendly due to this dichotomy. Moreover, any water that approaches Proxima Centauri would be boiled away by its strong radiation. On the other hand, if a planet is too far from its star, it would freeze and its water supplies will become inactive. Proxima Centauri is a difficult planet for life to survive in, despite its small size. Because of its tiny size, the star's nuclear fusion activities are closer to the surface, causing erratic and chaotic surface activity. High-energy radiation and particle bursts are produced by the strong magnetic fields created by these turbulent conditions. Planets that orbit within the star's habitable zone, such as Proxima b, face major challenges as a result. The specific magnetic field conditions surrounding Proxima Centauri were unknown to astronomers until recently. This issue has been clarified by recent high-resolution magnetic field images, which show that Proxima b receives about 1,000 times as much solar wind radiation as Earth. The possibility of life on this far, off-world is threatened by such high radiation, particularly during strong flares that are 100 times more potent than any seen from the Sun. The prospect of coming into contact with extraterrestrial life has long captivated us as humans. This curiosity peaked around the end of 2020 when a strange signal from the Alpha Centauri system was discovered. 9825 and 51 MAVs were unusual frequencies for this transmission. Perhaps alien life is not as implausible as previously believed. In order to significantly cut travel time from hundreds of years to only a few decades, the breakthrough initiatives have conducted research. Current technology may be able to overcome the problem of accelerating things as their mass grows, especially as they get closer to the speed of light, according to recent studies. But even with these improvements, it would still take about 6,000 years of travel time with our existing technology to reach Alpha Centauri, the nearest star system to Earth, a difficult task. The Starshot project considers using lasers as a spacecraft propulsion system in order to reach Alpha Centauri. The atmosphere of our planet, however, is the main barrier since it obstructs incoming light and laser beams, making it challenging to provide the force required to move a spaceship forward. The first author of the study, Tonga, suggests a remedy that uses adaptive optics in reverse. Ground-based lasers would be able to keep a tight focus on the space mission, while small lasers placed on satellites would evaluate atmospheric effects in real time. The lasers used in this ambitious project would need an incredible 100 GW of power, which is equal to all of the electricity used in the United States. To disperse this energy over a 1 square area, these lasers would only need to run at full capacity for a short 10-minute period. It envisions a network of 100 million lasers. The crew behind Starshot is unwavering in their resolve to further space exploration. In order to achieve perfection, the probe's integrity must be maintained, and it must be shielded from the hostile environment of interstellar space. The probe needs a flawlessly crafted mirror that can reflect 99.99% of the light it comes into contact with in order to prevent melting. It also needs to minimize heat over a few days and quadruple the momentum transfer. The probe would travel through the Alpha Centauri system after launch, possibly never approaching any planet it came across. Exploring nearby star systems is made possible by the interesting idea of launching a fleet of probes. The likelihood of finding Earth, like planets, is greatly increased by sending more probes to adjacent systems. If we were to investigate the entire Proxima Centauri system, just think of the tremendous ramifications and countless discoveries that might result. It begs the intriguing question, how many more planets like ours could there be? Exoplanets, or worlds outside of our solar system, are still fascinating topics for scientists, and many of them have already been discovered. The finding of planet-circling pulsars, a specific class of neutron stars, in 1992 marked the beginning of the search for these alien worlds. Scientists discovered the first planet orbiting a star similar to the Sun 3 years later. Since then, several more planets have been discovered, including a few Earth-sized worlds inside the habitable zones of their stars. Our knowledge of the cosmos has advanced to unprecedented levels thanks to ground-based studies and groundbreaking missions like the Kepler Space Observatory and the James Webb Space Telescope, JWST. However, our understanding of the cosmos is far from complete. Every new finding serves as a springboard and an opportunity to explore the universe's mysteries deeper. As we think about Proxima b, its captivating features entice us to consider the potential of extraterrestrial life. The breathtaking exploration of Proxima b and the boundaries of space leaves us feeling awed and excited. But the severe conditions of its surroundings, such as high radiation and sharp temperature swings, remind us of the difficulties in maintaining life outside of our home planet. Once considered science fiction, the possibility of interstellar travel is now being investigated scientifically. Initiatives such as Starshot stimulate our collective imagination and push the limits of our technological capabilities. Our unquenchable curiosity keeps us moving forward, encouraging us to explore the unknown and appreciate the great mysteries of the cosmos, even though we may not yet have all the answers. The pursuit of interstellar travel is a huge undertaking in the vast scheme of cosmic exploration. In the future, humanity will be able to travel beyond the boundaries of our solar system and explore the unexplored regions of nearby star systems. According to the visionaries behind initiatives like Starshot, examining the complexities, difficulties, and possible discoveries that might open the door for interstellar travel is crucial as we stand on the brink of this exciting adventure. With its audacious objective of reaching Alpha Centauri, the Starshot project embodies the spirit of scientific innovation and human tenacity. Using lasers as a propulsion system challenges the accepted ideas that have guided our comprehension of interstellar distances and offers a fresh perspective on space travel. However, the Starshot team pushes the boundaries of what is technically possible by tackling the many obstacles that come with innovation. The Earth's atmosphere, a dynamic and constantly shifting material that obstructs the path of incoming light and laser beams, is the primary challenge facing the Starshot project. Creative ideas are needed to get beyond this obstacle. Adaptive optics in reverse is a novel idea put out by Tonga, the paper's initial author. Ground-based lasers would be able to keep a perfect focus on the space mission, thanks to tiny lasers placed on satellites that would continuously evaluate atmospheric impacts in real time. It is astounding how much energy is needed for such a bold undertaking. The Starshot project's lasers would require an incredible 100 GW of power, which is equal to all of the US's electrical usage. Nevertheless, these lasers' intensity would only have to run at full power for a short 10-minute period, highlighting the predicted accuracy needed for interstellar travel. Astronomers have a problem when they go to Alpha Centauri, the nearest star system to Earth. The estimated journey time using our current technology is still around 6,000 years, despite the suggested improvements in propulsion methods. The magnitude of this time scale emphasizes that in order to make interstellar travel feasible, significant advancements in propulsion systems, energy sources, and spaceship durability are required. The Starshot project's conceptual visualization creates opportunities to imagine how space exploration may develop in the future. The likelihood of finding Earth, like planets in nearby star systems, improves tremendously with the deployment of a fleet of probes outfitted with cutting-edge instrumentation. This fascinating idea raises concerns about the possibility of extraterrestrial life and the habitability of exoplanets, opening up a new area for scientific investigation. The increasing frontiers of research beckon us as we consider the intriguing issue of how many more planets like our own might exist. Scientists are still fascinated with exoplanets, or worlds outside of our solar system. Thousands of these far-off worlds have been revealed by groundbreaking missions like the Kepler Space Observatory and the James Webb Space Telescope, JWST, offering insight into the enormous diversity of planetary systems. With its fascinating features, the breathtaking investigation of Proxima b challenges us to think about the potential for extraterrestrial life. Its hostile surroundings, which are characterized by high radiation and sharp temperature swings, serve as a sobering reminder of the difficulties of supporting life outside of our home planet. However, these difficulties only strengthen our determination to investigate the universe and push the limits of our knowledge. Maintaining the integrity of probes while they travel through the hostile environment of interstellar space is part of the pursuit of interplanetary exploration excellence. For these probes to survive, carefully crafted mirrors that can reflect 99.99% of the light they come into contact with are essential. Navigating the Alpha Centauri system and maybe finding new cosmic wonders requires striking a precise balance between reducing momentum transmission and decreasing heat over days. The Starshot project is a prime example of the unrelenting quest for excellence in space exploration because of its ambitious objectives and creative methods. The project's enormity and complexity necessitate state-of-the-art technology, unshakable commitment, and a shared vision that goes beyond the limits of present scientific knowledge. The intriguing question that emerges as we look to the future of space travel is, what amazing discoveries are in store for us as we venture into the cosmos? A future in which the wonders of the cosmos are revealed before our very eyes is hinted at by the continuous technological progress and the steadfast human spirit of discovery. The search for sentient life outside of our solar system gives the cosmic story much more fascination. When a strange signal from the Alpha Centauri system was picked up, the excitement surrounding the prospect of meeting alien life reached previously unheard of heights. There was conjecture regarding the existence of intelligent life because of the anomalous frequency of 9,827 MHz, which differed from the usual signals released by man-made objects. Traveling to the stars, especially Proxima Centauri, requires conquering formidable obstacles. Motivated by the goal of significantly cutting down on travel time, the breakthrough initiatives have looked into creative alternatives. There is some hope for accomplishing this once impossible accomplishment thanks to recent studies that look at how objects accelerate as their mass rises, particularly as they get closer to the speed of light. Our perspective on space exploration is drastically altered by the Starshot project's consideration of employing lasers for propulsion. The careful preparation, which includes everything from energy demands to adaptive optics, highlights how interdisciplinary this scientific project is. Even while the Starshot team is unwavering in their resolve, the enormous undertaking that lies ahead calls for the pooling of knowledge, resources, and a common vision for the direction of interplanetary travel. Space exploration has a bright future, and the difficulties that lie ahead motivate us to work together to remove the obstacles separating us from the universe. We proceed one step closer to solving the universe's riddles with every new discovery, paving the way for the future. We are moving toward a day when the wonders of the cosmos are not only seen from a distance, but also experienced up close thanks to the unrelenting quest for knowledge and the unbreakable human spirit. There are seemingly endless opportunities for space exploration in this age of growing frontiers and unparalleled technology developments. Even while the path to the stars may be difficult, human ingenuity, tenacity, and unrelenting curiosity guarantee that we will keep pushing the limits of our knowledge. We are on the cusp of a new age as we set out on our cosmic odyssey, driven by the aspirations of visionaries and the commitment of scientists. The universe, with all of its secrets, is waiting for us to discover it, and the border of space beckons. The potential of the human spirit to rise above constraints, aim for the stars, and discover the wonders that lay beyond the realm of our present understanding is demonstrated by the future of space exploration.